Hi friends, this video is going to be on how to simplify square roots and perhaps some other radicals. So first of all, just some vocabulary here. The square root sign is the most common radical, and it means that we're taking the second root. There's sort of an unwritten 2. So we're doing to take a root of something is to undo the square of something or undo an exponent. So we could raise something to the second power and then we could take the second root of it. We could square something or take its square root. And we could do that with any root. We could cube something and then take the cube root of it. But it's basically asking yourself, what number was multiplied by itself to get me this value? So you guys might know some basic square roots, right? Like the square root of 4. What was multiplied by itself to give me 4? Well, the square root of 4 is 2, right? Or the square root of 81. What was multiplied by itself to give me 81? Well, the square root of 81 is the same as saying the square root of 9 squared, right? And so the square root of 9 squared is 9. But what happens when you have a square root of something that isn't a perfect square, right? Like there's no number that I multiplied by itself or no exact number that I multiplied by itself to give me 12, right? Like 6 times 6, that's 36. I don't know. 3 times 3 is 9. That gets me kind of close. But then if I go to 4 times 4, that's already 16. That's already too big. So I have to see if there's a way that I can simplify this. Maybe partially, right? Like maybe I can't simplify it all the way, okay? So here's what I'm going to do. The first thing I'm going to always do is to make a factor tree. So 12 I can think of as 2 times 6. 2 is prime, I'm going to circle it. 6 I can think of as 2 times 3, and those are both primes. So now I'm going to write out this radical sign, the square root sign, and I'm going to list in here my factors. So I have 2 squared times 3. And so what I'm really doing is so just to give those some steps, one was list the factors. And then the second thing I'm really doing is I'm looking for squares. Right? Look for squares. Oops. So if I look here, I've got 2 squared. Well, and the square root of 2 squared is 2. The square root of 4, right, is 2. So I can take the square root of this 2 squared. That's 2. But I can't take the square root of this other part. I can't take the square root of 3. There's nothing that multiplies by itself to give me 3 exactly. So my answer is 2, right? The part I was able to take the square root of, times the square root of 3, which is this part that I wasn't able to take the perfect square of. So I'm simplifying it by taking the square root where I can, and then just multiplying it by whatever is left over, staying inside that radical. Okay, let's try another problem. So 63. So if I make my list of factors for 63, that's 9 times 7. Ooh, and if you get kind of good at this, so I already know something about 9, right? 9 is a perfect square. So I can either go ahead and rewrite that as 3 squared times 7, or I could write it as 9 times 7, since I'm sort of looking ahead in this problem to know that that's a perfect square. Square root of 9 is 3, but I can't take the square root of 7, so it just stays right inside that lovely radical. And we would say this as 3 root 7, or 3 times the square root of 7. Okay? Just a couple more examples so that you've got them. I would actually pause the video at this point and see if you can do them on your own, and then hit play and see if your responses are verified. So again, we're going to make a factor tree. So 72 would be 2 times 36, which, oh, wait, maybe I recognize that. Maybe I don't. Maybe I think of that as 2 and 18, and maybe that's 2 and 9, and maybe that's 3 and 3. Okay, so I'm just going to show you sort of what happens if I don't identify them right off the bat. Okay, so now I've got the square root of 2 to the third power times 3 to the second power. So again, it's the square root, the second root. So 3 to the second power, that's a square. So I can undo the square of that and write the 3 outside. But 2 to the third power, that's not a square. I have to be a little tricky. Is there a way that I could rearrange those 3 factors of 2 to make a square? And I actually think I can, right? What if I wrote this as 2 squared times 2? Haha, sneaky. So now this 2 squared, this is a factor. So 3 times 2, right? The square root of 2 squared is 2, times the square root of 2. When I end up with multiple coefficients, right, multiple numbers outside, all of these terms are still just being multiplied, right? So 3 times 2 times root 2 is just 6 times root 2. Neat, right? All right, 245, break it down, 5 goes in 49 times. Oh, and look at that, I already recognize that as a square. So this is the square root of 5 times 7 squared, or 7 root 5. Okay. I think that should do us for now. Please take a moment and see if you can simplify some of these roots that are not perfect squares. All right, thanks so much.